The world is getting crazier with ChatGPT. They want to explore, they want to know more about ChatGPT. Well, ChatGPT is also one of the mostly searched term in the internet in 2023. But what exactly is ChatGPT? What is the internal architecture? How does it work in behind? How is it able to generate large amounts of text? How is it able to help you with your blog writing, with your content creation, and lot more things? We will be getting into that in this particular video. So this video is going to serve as a knowledge guide on the entire concepts behind AI, generative AI, large language models, and we will also be exploring what are the other options apart from ChatGPT, because most of you know about ChatGPT and most of you might not know that ChatGPT has a lot of alternatives as well. We will also be winding up this particular video with an end-to-end case study around generative AI, and we will be exploring an alternative of ChatGPT and we will try to build a LLM-based chatbot. Also, we are going to deploy the chatbot using Flask application, so stay till the end. For this particular video, most of the initial topic discussions are going to be done by me, but for the later half of the video where we will be implementing LLM code wise and then we will be deploying that into a Flask application, we have another guest. I will be doing an introduction to him shortly. What exactly is artificial intelligence? Now, AI is nothing but, obviously we know the definition is artificial intelligence. That means some sort of intelligence that is achieved artificially. Now, there are various areas of researches that basically leads to AI, and one of these areas of researches are machine learning, natural language processing, deep learning, computer vision, automation, autonomous vehicles, and many more fields that basically leads to AI. Now, generative AI is nothing but a part of artificial intelligence. In short, generative AI is that part of artificial intelligence that helps you to generate or create new content such as text, images, music, or videos that is originally and not directly copied from existing data. Now, talking about large language models. Now, are large language models generative AI or vice versa? Are generative AI large language models? Well, generative AI is the overall picture, the generative part, the generative artificial intelligence, and it has both LLM and non-LLM part. Now, LLM has become famous because ChatGPT is a LLM model, which is nothing but a large language model. So, in simple terms, in layman's term, what exactly are LLMs? LLMs or large language models are powerful artificial intelligence models that are trained on vast amounts of text data to understand and generate human-like text. These models basically use deep learning techniques such as transformer architectures to process and generate text based on the patterns and structures they have learned from the training data. Now, as we know the basics of LLMs, what are different kinds of LLMs in the market? Now, if you want to know more about generative AI and LLMs, however, I have just talked about one sentence or two sentences, but if you want a detailed video on generative AI or LLMs, please let me know in the comment section and I will come up with either a video or a affordable course, whatever it is, but most likely a video because I don't want you to pay for anything. So in case you have any questions, let me know in the comment section below. Coming on to this topic of LLMs, large language models. Now, I'm not going to go in depth into the architectures. As I told you, if you want that video, let me know and I will come up with another video. In short, LLMs, there are multiple types of LLMs, one of them being ChatGPT. Now, ChatGPT became famous because it basically created an interface where people can log in, people can start talking to it, and people will be able to get the responses back. Now, it became very famous because it was free of use. And later on, when people started using it, they basically started making some changes to their models. They introduced 3.5, then they introduced GPT-4, and then they started charging users like $10 a month or something like that. So that's how it became famous. And now ChatGPT, being a part of OpenAI, is being acquired by Microsoft. It is going to get a huge boost. But apart from ChatGPT, there are many more LLMs that are easily available and can be free of cost. You don't have to pay anything for that. What are those? One of them is Google Bard, which is basically by the Google team, and one of them is Llama, L-L-A-M-A, and it is by Meta. Apart from these two, there are various other LLMs like GPT-3 by OpenAI, GPT-3.5 and GPT-4 by OpenAI. So that's all about some of the basic concepts behind AI, generative AI and large language models. So let's get started with the use case part, which serves as an end-to-end project for you guys. People who are interested in the generative AI or large language models or deep learning part, they can explore this particular project and work on it. So in this video, I have a friend, I have a colleague, I have a partner, I have a community member whose name is Mr. Vasant P. He's also a YouTuber. He runs a YouTube channel and his channel link will be in the description below. And he works as an AI developer with 𝐓𝐢𝐻𝐞, 𝐓𝐢𝐻𝐞. I think most of you might be knowing about the company. Now, I'll hand over the mic to him and he's going to demonstrate about which LLM he's going to use and how is he going to leverage that LLM to create a LLM-based chatbot. And ultimately, he will take the LLM chatbot to the next level by deploying it into a Flask application, and he will show you how he's interacting with the chatbot. The codes will be given to you for sure. I don't want to keep the codes with myself. Codes will be given to you, but at a cost of 200 likes and 50 comments. So in case you have any questions around this space of generative AI, LLMs, chatbots, GPTs and all those things, let me know in the comment section below and I will get back to you. 200 likes is what I want to give you the codes freely. Access it, deploy your own LLM chatbot, enjoy your Flask application, write your project in your resumes. Best of luck to you. Handing over to Vasant. Here we go.
Yeah, thank you, Satyajit, for the amazing introduction which you provided. So in this, we are going to see how to fine-tune Mistral LM, Mistral 7B to create a chatbot, which will be like ChatGPT, but not ChatGPT. This is something else, right? So it has given great performance, which I'll show at the end of the video, where I'll be showing a Flask application. I would not be delving deep into the code of Flask. I'll show how the calls happen. That's there, but I wouldn't be going deep into how it works. Okay, I assume that you all know how it works. Okay, so with that being said, first let me say few words about Mistral 7B, about the organization and how it works behind in Mistral 7B, and then we'll move on to the coding part, which I have a separate collab notebook for which it is there. Yeah, so this is the website of Mistral AI. So they have said that it is the best 7B model to date, Apache 2.0 licensed. Okay, so probably it is an arguable point right now, because OpenArca organization, what they did was they took this Mistral 7B itself and then they fine-tuned on their own dataset called OpenArca, which is again going to be Mistral for sure. But yeah, their base version it might not be the best model right now. Okay, but still it has given some great result. But we are not going for the base version, we are going for the instruct tuned version in this fine tuning. Okay, so if you see, the website was created on September 27. So by that date, it was the best. Yes, it has outperformed every 7B model, but not just 7B models. It has also outperformed 13 billion and 34 billion model. Okay, so it has written here, right? See, outperforms Llama 2 13 billion, outperforms Llama 1 34 billion, and it also approaches on Code Llama's performance. Okay, so this model, if you see, it is not purposely created for coding. Okay, it is an LLM, general LLM, general purpose LLM, but still it gave great performances with coding also. But in case of Code Llama, it was just for coding. But yeah, still it came closer to code Llama. So that is pretty good. Okay. So there are some advantages in this architecture. First is they are fast in inferencing, and the reason behind is they are using group query attention. There is a attention mechanism called group query attention, and what it will do is it will have a number of queries being grouped and provided to single key and single value. Okay, so that is group query. And then they have also provided sliding window attention, which will support up to 128k tokens, which is being specified in their paper. Okay, so up to 128k tokens it will support when you are fine tuning or even when you are inferencing, which we won't need because we won't have that much computation. But let's say you have an use case and you have the computation, then yeah, you should be able to use Mistral 7b itself for your long documents and all. Okay, so they have released it under Apache 2.0 license, which means commercially it is usable. Okay, and here is the main thing which you need to note. Okay, performance comparison. I'll just go through this graph in a minute, and then we'll go on to the collab notebook. Okay, so here we have the comparison. Okay, so orange is Mistral, green, light green is Llama 134 billion, teal is Llama 213 billion, and red is Llama 27 billion. Okay, when it comes to MMLU, it has given outperformed all of these. Okay, and in knowledge category, it is slightly lower than 34 billion, but still it has given as much as the performance with 13 billion. Okay, and in reasoning, it has been surpassing all the models. Same with the comprehension. Okay, but when you come to the other side, right, in AGI eval, which is it is to check how much it is autonomous in nature. Okay, so in that it has outperformed literally all models with a very significant margin. And similarly, it worked with math and code. In BBH, which is Big Bench Hard benchmark, it was slightly underperforming than 34 billion, but still it has been pretty good. See, 7 billion model outperforming 34 billion, which is around 5x its size, but it has outperformed with significant margins. That good is this model Mistral 7b, which I think we can term it as open source beast. Okay, so that is what you need to know about Mistral 7 billion from the organization known as Mistral AI. So with the introduction being said, let's go on with the fine tuning. Okay, so let me open the collab notebook now. Here we have the Google Collab notebook. So the first step in the fine tuning would be is to install the dependencies required. So here I have accelerate, peft, bits and bytes, and installing transformers. You should install it from the source for this video, because at the time of this project, Hugging Face hasn't released the version with Mistral support in pip. Okay, so the pip package isn't released yet, so you can install it from the source, by which only you will get the support for Mistral, and TRL library for transformer reinforcement learning, which will help you to use SFT trainer, which will act as our trainer in this project. Okay, and we have auto GPTQ, which we will be using for GPTQ quantized model. Okay, because this video we'll be fine tuning the model in a GPTQ quantized way. Okay, a GPTQ quantized model only would be fine tuned in this video, so that's why we need auto GPTQ. And optimum, it is also a requirement when you are fine tuning a GPTQ quantized model. Okay, so these are the dependencies which are required for this project. So I hope you all know now that these are all the things which we need to install usually. So yeah, now we'll start with the import. Before going on to import, just to let you know that it is very important for you to create an account in Hugging Face Hub and then log in by providing the API key. So let me show you how to do that. Okay, so just go on to Hugging Face. So this is my profile. Okay, so just click profile here. Once you create the account, that is when you should do all of these. Click settings, click access tokens. So you all might not have these tokens. Okay, so what you can do is click new token, have this as something like maybe Mistral chatbot. Better not leave space. Mistral chatbot, and I have the role to be right, because if you don't provide right access, you won't be able to push your model to the hub. Okay, so it is very important for you to have right access. So yeah, just copy this, and once you run this, obviously you'll have a token being asked. You can provide in there. Okay, so that is about the login. Now coming on to the importing dependencies. Since we have installed it, now we can start with the import, followed by which we can go on to the fine tuning part. Okay, so the first import is Torch, because we are using Torch framework to work with this. So yeah, the first import would be Torch. Then we have load dataset function, which will help us to load the required dataset, and dataset class, which will provide us the functionalities to play with Hugging Face dataset. Okay, so whatever dataset we load by using load dataset, it is a dataset class, and to harness the functionalities we need this dataset class. Okay, so yeah, now coming on to the PEFT, we have LoRa config. So LoRa config is required for you to create your LoRa adapters, and then auto PEFT model for causal LLM. So this, I'll come on to this into the later part. So next we have prepare model for k-bit training, which will help you to prepare your model for k. K is some arbitrary value, in which here it would be 4-bit training. Okay, prepare model for 4-bit training, and then get PEFT model. It will try to create your parameter efficient fine-tuned model based on the config you created for LoRa. Okay, so in transformers, we have auto model for causal LLM, auto tokenizer. Auto model for causal LLM will call the model, and auto tokenizer for your tokenizer. GPTQ config for specifying the config of the quantized model, and then training arguments for you to provide your training arguments. Okay, so basically your batch size, number of epochs, and yeah, so on and so forth, which we will be seeing in some time. All right, so next we have SFT trainer being imported from TRL. So SFT stands for supervised fine tuning. So this is a type of fine tuning which we are doing right now. Supervised fine tuning trainer is being used. Along with that, we have also have OS package. Okay, now coming on to the dataset part. So here I'm loading alpaca dataset. Okay, so this is a famous conversation dataset. Let me show you here. So here is the dataset, which if you see here, if you give an instruction stating gives 3 tips for staying healthy, and the output would be eat a balanced diet and so on and so forth. Okay, so this is how it would be. But the key thing to note is alpaca datasets has its own format. Okay, so that is something which we need to note. So let me show that here. Okay, here we have 3 columns, which is very important for us: instruction, input, and then output. Okay, just keep this in the note. Now I'll come on with the code. Okay, so once you call the load dataset function with the dataset ID, which we pasted here, right? This is the dataset ID. You can just click copy here, it will copy, and then you can paste it here. In that, we are calling the train split alone. Usually it will have a lot of splits. We are just taking the train split data alone. And then once it is done, we are converting it into pandas, so that it is very easy to work with pandas data frame rather than a Hugging Face dataset. So yeah, we have converted into pandas data frame for limiting the time of execution, and for faster execution, obviously. I've restricted this to 5,000 data points. Again, we won't even be using 5,000 data points. You'll understand that once you come on to the training argument section. I'll be explaining there. But yeah, if you think, okay, I'm just gonna run it for how much ever time it is there, so it is fine, because if you see the dataset has around 52k rows. If you think that you have computation for 52k rows, just go on with that, because if you run it for 52k rows, you'll get a great result for sure. Okay, so yeah, now in SFT trainer, it expects all the text should be to be in a single field. Okay, single field. single field is like single column. Okay, so I just create a new column called text, in which I'm calling the apply function on top of input, instruction and output, all the three columns. Okay, how I'm combining is, this is alpaca prompt template. Okay, first you'll have hash 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 human, and you'll provide the human instruction. If there is some input is also being provided, and along with that you will also provide the assistant, so that it will know, okay, you have provided the input, that is fine, from now on I need to provide the output. So that is what it will recognize when you see assistant. Okay, so that is how you need to combine human, your instruction. So here if you see instruction is there, input is empty. If the input is there, it will also come here. Okay, so identify the odd one out: Twitter, Instagram, Telegram. Okay, so yeah, now with that being said, you will combine the instruction in input, followed by that you will have assistant being combined with this. Okay, so once that is done, hereafter it will try to fill, okay, x of output. So yeah, since we are using cos LLM, there is no such thing that this is input, this is an output. Okay, in cos LLM it will always try to generate the content, so wherever you stop it will try to generate from there, and here we'll stop always from assistant is 2 and 1 space. Okay, so that is how it is framed here. All right, now since we are completed with the processing, we need to again convert this into a Hugging Face dataset, because that is the required format for the trainer. So we are calling the from pandas function, which will create Hugging Face dataset based on a pandas data frame, which is here data underscore df. Okay, now the next step is to create the tokenizer. So before going on to the tokenizer, let me show you this model, because this is the model which we are going to use. Okay, we are going to use Mistral 7b instruct version, but it is GPTQ quantized. Okay, so that is what we are going to use here. So this is from the blog. Okay, there is this person, he always uploads the different quantized versions of model: GGUF, GGML, AWQ, GPTQ, and we are using the GPTQ format. Okay, so yeah, from here we are calling the tokenizer. So here you can see, right, tokenizer JSON, tokenizer model, everything is there. Based on this, auto tokenizer will try to create the tokenizer, and we are setting the EOS token to be pat token, which is very important. Okay, it will just say that, okay, this is the end of sequence token, and you can stop the execution here. So that is how it works. All right, next is quantization config. Okay, so here we are using GPTQ config, which is 4-bit. So we are set that GPTQ config bits is equal to 4, disable 𝐓𝐢𝐬𝐿MA is set to true, and then we are also providing the tokenizer. Okay, so if you have this, now you are saying, okay, this is the quantization models configuration. So based on this, we are loading the model. That is what is happening here. And device map set to auto, what it will do is, it will try to allocate the layers of model with some CUDA device. Okay, so if you have multiple devices, it will try to efficiently map it to multiple devices, CUDA devices. But here we have only single GPU with Google Colab, so it will try to map everything to the 0th device. All right, so next we have model.config.useCatch is equal to false, which means we are setting that we are not inferencing it, we are training it. Okay, so that is what happens with useCatch equal to false, and pre-training TP is equal to 1 is to replicate the performance of pre-training. Okay, these are all some configurations which is need to be set prior to training. So yeah guys, keep it in the mind. So next we have a gradient checkpointing enable, which will help us to checkpoint the gradients and use it. And also we have prepare model for k-bit training. Like I said, here it is bits is equal to 4, right? So it will become prepare model for 4-bit training. That is how this model will be created. Now the model is ready for 4-bit training. Okay, now next what? So you might think, Vasan, the model is ready, so now shall we go on to the training? No, like I said, here we are using LoRa. Now you might think, Vasan, why is LoRa needed? You see, these models are pretty huge. Let me go and show you the size here. Okay, so it is 4-bit quantized, yet it is 4.16 gigs. And if I'm going to show you the original size, right? So let me go for Mistral here. Sorry. Here we have the original model, which is of size around 14 gigs, right? Which is very huge. So here, to compute faster and train faster, the researchers recently created a method called LoRa, which is low rank adaptation of large language models. Okay, which states that with small weight decomposition matrices itself, you will be able to fine tune the model and achieve the same performance which you will get by fine tuning the full model. Okay, so let me give you a one liner of how it works. So what happens is, let's say you have a model, you'll try to create adapters for it. Okay, so what happens is, here is the original weight. I hope it is visible here. Okay, here is the original weight, and here is your LoRa adapters. So once your input goes, first these weights will be frozen. Okay, this won't be trainable, it will just go forward and come. There is no backward pass here. Okay, this is just for computation, and this would be trainable. Okay, your LoRa adapters. So based on this, you'll be only fine tuning the LoRa adapters which you provide. Okay, so that is how LoRa adapters work. It is a detailed concept. So yeah, but right now you won't need that much. You need to know some of the aspects of LoRa alone. Just know that with smaller matrices itself, you will be able to achieve the performance. That is the core of LoRa. And here are some things which you need to know important on LoRa configurations. Okay, so here we have LoRa rank as 16. R stands for LoRa rank. So smaller the rank, lesser the performance. So in the paper, LoRa paper, they would have specified that even 8 is suffice enough, but I have gone for 16. But yeah, 8 is also suffice enough. But if you go for 4, it will be faster. With lesser memory itself, you will be able to execute it, but there will be slight degradation in performance. So you need to find the trade-off between the performance and training computation resources. Okay, LoRa alpha is equal to 16. It is a trainable, not trainable, scalable value. Okay, it will try to scale the weights. So that is why LoRa alpha is there. And then dropout, it is very usual, like our normal dropout only. It will also work for LoRa dropout. We are setting the task type to be causal LLM, because there is another type called sequence to sequence LLM, right? So here we have only causal LLM. And next we have target models being set to 𝐞𝐲 and 𝐕𝐷. See, usually with LoRa, right, you need to provide some target modules. So with the target models, it can be your attention layers, it can be MLP, which is your linear or dense layers, whatever it is you can provide. Here we are going for the attention layers. Okay, especially 𝐞𝐲 and 𝐕𝐷, as per their specification in their paper itself. They would have specified that with query and value layers alone itself, you'll get some very good performance. That is what they would have specified, and we are following that. Okay, so that is how the LoRa adapters config is. So now that the adapter config is set, it is time to attach those adapters with the base model, which is done by getPef model. Okay, when you call the getPef model, based on these adapters, it will adapter config, it will try to create adapter, and it will try to attach those to the model. Okay, so that is how it is with model equal to getPef model of model comma pef config. That is how it works. Okay, so next we have the training arguments. So inside the training arguments, there are a lot of arguments to be provided. So these are some parameters which is very essential. I'll explain each of these now. Output directory is your output directory. I think that is not needed of much explanation, right? Next we have per device train batch size. It is named such because like I said, if you have 3 GPUs, right, here we have set per device train batch size to be 8. So your batch size effectively would be 24. Okay, so per device 8 and 8 cross 3 would be 24, but here we have only 1 GPU, so it will be 8 itself. Okay, and then next we have gradient accumulation steps. So what is this gradient accumulation step? So if you have worked with PyTorch neural network, right, we call this step function usually. So what this gradient accumulation steps does is, it won't call the step function for every step. Okay, it will try to accumulate the gradients, and for a certain period of time. Obviously, if I have given 1 here, if you have given 8 steps, it will go till it will wait till 8 steps accumulating all the gradient, and then it will update it. Okay, so if you keep higher gradient accumulation steps, the training time should be slightly faster. Okay, next we have optimizer being page random W32-bit. This is a special optimizer created to work with quantized models. Okay, so if you have quantized models being fine-tuned, then you should use page random W optimizer. Okay, next we have learning rate set to 2e-4. This is a basic learning rate which is used right now, starting from Llama. It is a common learning rate being used. Next we have learning rate scheduler type to be cosine. Okay, and save strategy as epoch, which wouldn't make a difference here, but it will make a difference when you comment the max steps. Okay, so let me say what are about max steps and logging steps. Okay, logging steps, what it will do is it will try to evaluate at the given step, which is 100 here, so 100 steps here. So at 100 steps it will try to evaluate and then provide the loss. That is what logging steps means. Max steps, what is that is, you see there are 5000 rows here, but the training happened only for 2000 rows. So you might wonder, Vasan, how it is. See, max steps is for you to restrict your training to some arbitrary number of steps, and here I restricted it to 2000. So still you can wonder, Vasan, there is only 250. So how the calculation works is, you have the training batch size, right? You should see the effective training batch size, not the per device training batch size. Okay, like I said, here it won't make a difference, but if you are working with a multi GPU server, it will make a difference. So here we have 8 as our effective training batch size. 8 multiplied by 250 would be 2000. Okay, so that is why it is executed only for 2000 steps. But you can also comment that max steps 250 to be out. Okay, I don't need this restriction at all. So yeah, if you think that like that, you can just comment the max steps and then execute it. It will work still. Okay, but the training time will take some more time. Okay, so we have FP16 set to be true, which will train the model in a mixed precision. So FP16 is a mixed precision training, so we are also enabling that. Finally, we are also enabling push to hub to be true. What it will do is it will try to push the adapter model and adapter config and your tokenizer and all to the hub. Okay, so that you can later call it for your inference, which we'll also do here with creation of the chatbot. Okay, so that is about the training arguments. Finally, we have the trainer here, in which it will take the model parameter, training dataset parameter, which we are also created it. Okay, model is the get_pef model output. That is what is your model here, and we have the pef config, which we loaded. Okay, pef config is the LoRa config, and just to let you all know, there are other pef methods as well, like there is IA3, there is prefix tuning, prompt tuning, there are a lot of other methods, but we have gone for LoRa because that is currently the best way to fine tune your model with parameter efficient approaches. Okay, we have the dataset text field to be set as text. Like I said, it will expect to have a single field or single column, which we created, right, under the column name text. So we are providing that here. We are also providing our training arguments, tokenizer, max sequence length to be 512, and packing equal to false. You see, what they do is, if you don't have the sequences to be of the max length, right, they will try to pack the next sequence with the previous sequence itself. This will help at some times when you are doing pre-training, and also that's why they have given this functionality, but we don't need that, so we have specified that packing is equal to false. And then finally you can call the trainer or train function, which will train the model. So that is fine-tuning Mistral 7B for you all. Okay, so if you have a custom use case, all you need to do is just have this dataset processing side to be changed. Okay, so still the other code remains the same. You can use the same code for any project you want. Just make sure that you will be creating the dataset in a single field call text. It should result in that. Okay, so that is the aim when you are fine-tuning it for any use case of your own. So here if you see, I ran it only for 225 steps, right? And 250 rather, yeah, 250 steps. And for logging, it happened at 200 steps and 100 steps, because the logging steps is set to be 100. At the end of 200 steps, it is 1.24 logs, which is okay. Okay, it's pretty good actually for a quantized model. And what I'm doing is, for safety concerns, still it is pushed to hub, but for safety I mounted the drive and also copied it to the drive. So if you want, you can do it, or else if you don't want, you need not do it. Okay, I'm not going to show the inference here. I have an application, so that it will be more better as an application, right, when you are inferring it. So let me show the application right now. Okay, let me fire up the VS Code. So yeah, here we have the VS Code. Okay, in which we have Flask class being called from the Flask. Okay, so again, this is a Flask application. We have the Flask class being called along with a render template, which will help you to render your template, which is your HTML page. Okay, and then we have request to call to provide a request from front end to the back end, and JSONify to basically provide a JSON response. Okay, so that is why we need JSONify. Here the important thing you need to have is the chat. From chat, import chatbot. This is the important thing we should note, because these are all simple things where you need to call the front end. I'm not going into the front end part. Okay, I'll show you only one thing. So here in chat.html, I'm not going at every places. So here you can see there are JavaScript being provided here, and yeah, here if you see, there is the send button, right? What happens is, if you call the send button, if you click the send button, obviously from the front end, it will call to this backend. Okay, so that is how the post comes. All right, so let me go on to the chatbot file right now. But yeah, before going on to the chatbot, I'll also like to show you the fact that how it is being rendered in the front end. Okay, so here if you see response.answer, right, this is what it will do once you provide this post request. From here again, the response will be provided, which is answer here, and that answer will be called here. Okay, so that is being displayed. So that is how the pipeline works basically. But the thing we need to notice, chat.py file. Okay, so this is the main file for inference. So still, if you are feeling okay, I'm not good with HTML, I can't go for Flask and all, still you can write a Streamlit application and call this itself again there, still it will work. Okay, so here we have the AutoPef model for causal LLM. What it will do is, now we saw how to create the PEF model, right? You will create the LoRa config, you will call the get PEF model, everything you'll do it, right? And auto model for causal LLM to call the base model, everything you will do by yourself. But when you do this AutoPef model for causal LLM, right? Once you provide the repo, it will try to get the adapter config, and based on that, it will itself call the auto model for causal LLM, and it will try to combine the PEF adapters by using get PEF model. So around 3 steps will be combined into the single step when you are calling this AutoPef model for causal LLM. Okay. Next we have the generation config. This is to provide or constrain your generation of the model, and we have auto tokenizer, which will create the tokenizer. Okay. So here you saw there, right? We provided as Mistral fine-tune alpaca, and it is under my name Vasant. In my user only it is there, right? So you need to provide that also, Vasant / Mistral fine-tune alpaca, and the model is also available there. So we are calling the first the repo ID. We are also setting the low CPU memory usage to be true, which will make it to consume the usage of CPU being very less. The torch dtype is set to float 16. So we saw, right, we were working on float present 16. So the touch D type is set to float 16 and the device map is CUDA so that we can use the GPS. Okay. We also have generation config in which we have set the top k to be 1, which will try to provide the topmost probable output, and do sample equal to true is set for temperature being used. Okay, why is this temperature parameter needed? Is to control the randomness of the generation. Okay, so usually large language models are very random in nature while they're generating, but we can control that by providing a very low value for temperature closer to 0. Okay, when you're closer to 1, it will be very creative and diverse in nature. We have the max new tokens also, max new tokens parameter also, which will have 100 as its value here. So why is this max new tokens? Is that will allow the model to generate up to 100 tokens. Okay, so that is why we have set this max new tokens to be 100. And finally, we have pat token ID to be set as tokenizer.eos token ID, which we also did while we were fine tuning it, right? So we are also doing that here. So that is something you need to know, or else you need to do before you're going for inference. Okay, these are all some pre-inference requirements. So to call the inference, the first step would be here the message is coming from the form and we are passing it via the chatbot, right? So the message will be formatted. We fine-tuned it in an alpaca format, right? So first we are creating it in such a way. So we are providing human, giving a space, combining the message. We are giving another space. We are providing assistant, and we are letting it to complete. Okay. Now, if you provide the inputs, so here we have tokenizer. The inputs, how it will be created is the tokenizer will tokenize these, and the input IDs would be written in a CUDA device. Okay, this will be CUDA tensors with the name input IDs. If you call the model.generate function, it will try to generate based on this, which will result with token IDs or output IDs, which you need to decode again with the tokenizer. Okay, so that is what we do here. We are decoding it, and we are skipping the special tokens if there is any, and have also set replace input string comma an empty string, because it will try to generate from the input string, which we don't need while we are getting an output. So we are calling the replace function here. So let us see how the output is right now. Okay. Yeah. So let me go for the terminal. You need to activate your environment with all the requirements. Okay. So let me call the Flask run. So here you can see it is being called. For first time, it will take some time for calling, because what happens is you'll have the model being downloaded first, and then it will load. So here I have already downloaded it. It will only load. Okay. So now it is ready. So let me go for the Chrome. Okay. So here we have the chatbot interface. Okay, it is a simple interface. So let me ask, I dropped my mobile phone in water. What should I do now? If you send this request, obviously it will take some time. Okay. So let us wait for that. Probably it should take around 3 to 4 seconds. So yeah, it is come. It is saying turn off the phone immediately, remove the phone from water and dry it thoroughly, use a hair dryer in a low setting to dry the phone, use a desiccant to absorb any remaining moisture, check the phone for any damage. If the phone is damaged, take it to a professional repair. If it is not damaged, since you have dried it, you are fine to use again. So yeah, it is pretty good, right? So yeah, we have a powerful chatbot which is running in your local system. Okay, and also we saw how to fine tune a quantized model. Okay, so that is about how to fine tune Mistral LM or else Mistral 7B here for a chatbot. Okay. Thank you all.
That's all about this particular video, guys. I hope you enjoyed it. In case you did, please don't forget to like, share and subscribe the channel and leave a comment in the comment section because that is most important. See you in the next video. Bye bye.